All right, now we are going to be looking at our second method for solving systems, and this is called solving by substitution. Our last approach was a lot of graphing, and this one is going to be a lot more algebraic. So you notice some steps up here. I'm going to take you through them, and I'm also going to give you some visual cues that will help. So the first step says isolate a variable. So it says sometimes this is already done for you. I'm going to be going through number 5 and number 7, the top two examples on this page. Number 5, this is already done for you. So what it means by isolate, it means that one variable is alone on one side of the equation. So notice I have y equals 2x. So what that means is y is the exact same thing as 2x. I can use them interchangeably. So substitution says whenever I see a y, I can change it to a 2x because they mean the same thing. So in the second equation, I see 7x minus y equals 15. Notice if I just replace 2x with that y, I'll have only x's. So 7x minus, instead of y, I'm leaving a blank, equals 15. So now this equation says the same thing as 7x minus y. We've just used 2x instead of y. So that's the substitution piece. You're replacing a variable with what it's equal to. So in this equation, now I can combine these. 7x minus 2x is 5x. 5x equals 15. Divide by 5 on both sides. And I have x equals 3. Boom. I already have what x equals. Now, in the first steps, I had to be very careful and make sure that I took one equation and subbed it into the other equation. So this was very careful. This used both the top equation and the bottom equation. I got one answer. Now from here, I take that one answer and I plug it into one of the two equations. I like to just see which one makes more sense to me. In my personal opinion, y equals 2x is a lot simpler to look at than 7x minus y equals 15. So I'm going to take x equals 3 and I'm going to sub it into y equals 2x. So instead of 2x, since x equals 3, I can say y equals 2 times 3. And now I know y equals 6. So my solution is 3, 6. I always write that solution as an ordered pair. So I isolated a variable. It was already done for me. I substituted that variable into the other equation, and then I used the solution to solve for the other variable. So this was step A, step B, and step C. Now the only thing I haven't done yet is checked my solution. So I can do that by taking 3, 6 and plugging it into these. So I'm verifying so in y equals 2x, y is 6, so does 6 equal 2 times 3? 6 equals 6, that is correct. In my next one, I've got 7x minus y equals 15. So 7 times 3 minus 6 equals 15. So that's 21 minus 6 equals 15. 15 equals 15. That is true. So there is step D. So I've solved, checked my solution. I know that's probably right. All right, and number 7, the first step of isolating a variable we still need to do. So one of the most important things you can do is select the easiest variable to isolate. Now, when I'm looking for to isolate a variable, I look for something that's almost already alone. So I'm looking for something with a coefficient of 1. And all you need to do is move the other variable to the other side. So I noticed that this y is looking pretty lonely there. All I have to do to get that y alone is add 5x to both sides. If I add 5x to both sides, then I have, so I'm starting with negative 5x plus y equals negative 2. If I add 5x to both sides, then I get y equals 5x minus 2. I could also have negative 2 plus 5x. I just always like to have my x in front of my numbers. So now that I know y equals 5x minus 2, I can take this second equation and I'm going to plug it in for that y there. So negative 3x plus 6. Now instead of y, I'm writing 5x minus 2 equals negative 12. So notice I just took this and I put it in place of the y. Now I have only one variable in the equation. So notice I isolated in here, I isolated in one equation, and then I plugged it into the opposite equation. You really need to make sure once you isolate, you're plugging into the other equation. So now from here, I'm solving a one variable equation. First, I need to take care of these parentheses using distributive properties. So I have negative 3x plus 30x minus 18 equals negative 12. I can combine like terms here and say 27x minus 18 equals negative 12. If I add 18 to both sides, I get 27x equals 6. Now I want you to know that I actually just had to pause my recording because clearly I needed to check if I was indeed supposed to get a weird answer. Now, I very well could get a weird answer. Don't expect no fractions in this class. However, I really just kind of thought for the second example, that's probably not going to be my answer. So I just looked back at my notes and I'm checking my work and I noticed 6 times 2 is not 18. It's 12. So I'm going to go back, change that to a 12. So now this is not an 18. So now I'm actually adding 12 to both sides. So really it's 27x equals 0. Now from here, if I divide by 27 on both sides, I get x equals 0. I'm going to move that up for you. See, now I'm sure if I was doing this live in class, someone would have called me out and said, excuse me, 6 times 2 is not 18, and this could have been avoided. But I wanted to show you that you can make a mistake, you can go back, fix your answers, and you can still truck along. So it's not a big deal to make mistakes. I just made one in the second video of this class, so welcome to class. So now that I have this x equals 0, I'm going to take that and plug it into one of my equations. I'm going to use my top equation. So I'm going to use negative 5x plus y equals negative 2. And I'm going to plug it in for the x. So -5 times 0 is 0. 0 plus y equals -2. So clearly y equals -2. So that is my solution, 0, -2. At this point, I plug in x and y into x and y in here, and you should be doing that on your own right now to double check the solution.